Hello and welcome to our second sequences video. So this is sequences 2, and today we're going to look at something called the nth term and try and understand what it is and how we might be able to find it. So as we always do, we need to start with understanding what the definition is of the nth term. So here we're simply going to say that it is the rule for a sequence. So previously we've looked at identifying a pattern in a sequence, and now we're looking at a specific rule to describe a sequence. So here we have a sequence 6, 10, 14, 18, 22. So the first thing we would be spotting from what we did before is that the sequence is adding 4 each time, and that the sequence starts with 6. So those are the two bits of information that previously we've looked at to be able to describe the pattern and the sequence itself. Now, what do you notice about adding 4? When do you come across adding 4? It's the 4 times table. So actually, when we talk about sequences, times tables are examples of sequences. So the 4 times table, which goes 4, 8, 12, 16, 20, is a sequence because it increases by 4 each time. Now our sequence also increases by 4, but it starts with a different number. It starts with 6. So what we're going to say is we're going to describe our sequence as being like the 4 times table, but we add on 2. If you look, 12 add 2 is 14, and 20 add 2 is 22. So 4 times table written out and add 2 onto each number, that is our sequence. Now we're going to put the algebra. Now we're going to put the n from the nth term in. So 4n plus 2. Now that's our 4 times table plus 2. So what does n represent? Well, n is simply the position in the sequence. So when we look at the first number in a sequence, we're talking about n being 1. And with the second number, n is 2, and then 3, 4, and of course the last number there will be the 5th term, so n would be 5. So n simply represents the position in the sequence of the number you're referring to. So let's try this again. Let's choose a different sequence. So now we have got 9, 16, 23, 30, 37. Okay, so first thing we're looking for is we're looking for that identifying the pattern, which is that we add 7 on. Now when we add 7, we are clearly going to be looking at the 7 times table. So we're going to write the 7 times table out so that we can do the comparison to be able to identify the rule for our sequence. So the 7 times table, but our sequence starts with 9. So what is the difference? The difference is we add 2. So we can write our sequence as 7n plus 2. 7 add 2 is 9, 14 add 2 is 16, 21 add 2 is 23, 28 add 2 is 30, and 35 add 2 is 37. So we've got a sequence that is 7n plus 2. Now, let's try one more and see if you can get this. Maybe pause the video before we give you the answer. Okay, so we've spotted the pattern. The pattern is we add 3. So obviously we now know that this means we're working with the 3 times table, because the 3 times table is always adding 3 to get the next number. So we know that the 3 times table can be represented as 3n. So our sequence, all we have to do is look at the difference. Now our sequence starts with 12 instead of 3. So we know that to make that happen, we would add on 9. 6 add 9 is 15, 9 add 9 is 18, 12 add 9 is 21, and 15 add 9 gives us 24. So there we have 3n plus 9. Now let's try something slightly different. We did look in our first video at sequences which were decreasing as well as sequences which were increasing. So let's see if we can do this with this sequence. 27, 24, 21, 18, 15 starts the same way. What is the pattern? The pattern is that we subtract 3 each time. So what times table can that possibly be representing? Well, as strange as it may sound, it's the -3 times table, which we don't normally learn, but it works. So you'll notice that the 3 times table, which goes 3, 6, 9, the -3 times table simply goes -3, -6, -9. Okay, so now we compare that sequence with ours, which starts with 27. So firstly, how would we write the -3 times table? We would write -3n to represent the -3 times table. How do we get from -3 to 27? That's right, we would add on 30. Okay, and there is our last nth term for this video. We'll catch you later.
The Force is with you, young Skywalker.